In this lecture, we are going to learn about what is known as inter-process communication. So what is inter-process communication? So first, to understand this, let's try to dissect this. Inter-process, so process communicating with each other. Okay, so processes are basically some tasks that are being performed and they want to communicate. So what will happen with that? So it's basically something like two people are working on something. Okay, so let's say I'm working with my friend and I'm making some dish. Okay, so two people are there. Okay, so both of them are working and he is cutting basically some vegetable and I'm cooking it on a frying pan. Okay, so both of us are basically interacting with each other and I will be waiting for him to supply me with the cut vegetable and then I will cook and so on. So these are basically some interrelated tasks. Okay, so but some person, if your one friend is studying here, so mostly he will have no interaction because his work is different. So the processes might be independent or they might be cooperating. Person in the kitchen and person in the study room, they might not be communicating, they are independent processes. But if two people are simultaneously making food and cooperating with each other, then they are dependent. So cooperating process can affect or be affected by other processes. Okay, if he is busy and he has not cut all the vegetables, he will be waiting for him. Okay, and then let's say his next task is to provide some oil to him. So again, they have some kind of communication. But he is just studying and he doesn't need them right now. Okay, reasons for cooperating process, of course. So one is information sharing. So if he needs, let's say, salt, okay, so he will ask this person that, okay, he will somehow needs to communicate that please bring me some salt and pepper. Okay, so they have to communicate. Computation speed up. Let's say both of them now they have a stove, two stoves, so they both will be making two dishes and it will become faster. Modularity also, he will be handling all the work of cleaning, let's say, and then something like cutting vegetables, and he will be frying them, he will be on the stove. Convenience, okay, so it is convenient, people are doing different works and then they are combining. So cooperating processes need inter-process communication. So similarly, if you are doing some process, so two processes, they are trying to do some work. Okay, they need to communicate. And how do they communicate? They use shared memory and then they use message passing. So they are the two different ways. So let's try to see shared memory. So we two are friends. Okay, and in fact, so they have a notice board. So one is working in a BPO, a call center, and what he does, he works at night and the other one works in the day shift. Okay, two people are there. So they need to communicate. Okay, so how do they communicate? They have a notice board there and he says that, okay, please cook for me. Okay, something like that. So that other person, when he goes in the morning and then the other person wakes up, he will know that, okay, what he needs to do. So this is a shared memory kind of process where two processes, they have a shared memory and that's how they interact. Message passing, two people, so let's say Bob and Sally. Okay, so they are friends and they say that, okay, they can send a message saying that, okay, let's meet at 4 o'clock. Okay, we will have some fun time. So Bob and Sally, so they can interact. So this is message passing. I can send some message and Sally has to receive that message. So this is how they interact. So this is another way of communicating. So this is how the processes interact, and operating system is very much similar to how humans interact. Okay, so how everything is related to person. So this happens, then communication model. So process A, process B, so that's how they're showing. So in terms of processes, so they have a message passing. So the process A must send some message to the kernel and from there it goes to process B. Okay, so kernel is the person here who has the messages, can communicate through him. So that's there. Otherwise they have a shared memory here and process A can write something into the shared memory, process B can read that thing. So this is how they communicate. And then you have producer consumer problem. So cooperating process, someone is sending message and the other one is receiving message. So your buffer where you write something, that can be unbounded buffer. There is practically no limit how much you can write, but bounded buffer assumes that there is a fixed buffer size, and which is the normal case. So let's try to see some more thing, okay, and that is basically synchronization. Okay, so how you synchronize. So there is a blocking or synchronous call where what happens if you send, if let's say I'm sending something, so that sender will block until that message is received. So it's some kind of, I'm going to some person's house and I will be knocking. Okay, so I will be knocking at his door till that person opens. I cannot just leave that message outside or in some mailbox. I will wait. Okay, so there is very some costly thing, and I will wait till that person or someone opens the door and I give him that costly gift or something. Okay, that is blocking send. Another thing is blocking receive. Okay, so that happens, I'm waiting for, on Valentine's Day, some girl is waiting that his boyfriend should send some message. Okay, so she is waiting and waiting till he gets the message, and then a smile comes on her face. So this is blocking receive. So something similar in the processes also. So process is waiting for some message, so like on a server, so it always keep on waiting for some request, web request to come. So it's blocking receive. Blocking send, what example you can think of? So you can tell me in terms of computers. So non-blocking calls or asynchronous calls, or what, a sender sends a message, he doesn't care if someone is there or not, he will put it in the door, at the door, and then he'll come back, or in the mailbox. So that is his work, and that somehow is in fact good also, that he doesn't have to wait. But what kind of thing you want, that you have to design based on your problem. Non-blocking receive, I will keep on polling, I'm not that much concerned. Okay, so I will keep, sometimes I check the door and see if some message is there. If there is, I take it, otherwise I again go and do my work. So that is non-blocking receive. So I hope you understand this inter-process communication till now, what I said. So synchronization issue and how they communicate, so using message passing and sending sharing memory, a shared memory, through that they exchange. So I hope you understand this. Thanks a lot.